In this video, we'll show the dataset of the lower polylogarithm of 1 minus x raised to the power k plus 1 all over 1 minus x and its Taylor series expansion. We begin with the dataset. So this is called the array formula. The quantity 1 minus x raised to the power the quantity k plus 1. This is k plus 1 and close the parentheses, divided by the quantity 1 minus x. So 1 minus x and enter. And the value of k, which is data validation, over the range 0 to 8 and enter. Save. So we can start from 0 and 1 and 2 and 3. Continue with the expansion, which is the summation of a times x to the power n, where the value of n is from 0 to k. So this is equal to sequence of k plus 1, one column, starting from 0, incremented by 1, and enter. So at k equals 4, that's our n is from 1 to 4. And the value of a, the coefficient, is array formula of n raised to the power 0. But we have to correct this because if this is empty, this should be 0. So we correct this. So if that's 0, if k is empty and 0, otherwise calculate. Now it's corrected, so this is empty, it's 0. Now we can complete the expansion. Array formula. Series sum of the x values raised to the power n, where n starts from 0 incremented by 1, and the coefficient will be this range. Enter. And we'll chart this. Insert chart. Their values are the same and their trend lines are the same. So we show the trend line. Series, trend line, polynomial to the 8th degree. And for the label, use the equation. We don't need the title because we already have the label. And for the legend, position at the bottom. So that's the position at the bottom for the legend. And we'll calculate this polynomial regression coefficient using LINEST. To do that, these are the polynomial coefficients. We use the LINEST matrix. That's array formula, starting with the LINEST matrix, array formula of the x values raised to the power 0 to 8. And we use LINEST. Data y and data x. And we use LINEST here also. Data y and data x. So let's start with k equals 0. At k equals 0, so here's our at k equals 0. At k equals 0, their value is 1. So this is y equals 1. So this is equal to 1. K equals 1. So that is 1 plus 1x. That's 1 plus 1x. All these are 0. 2.28 times 10 to the minus 15 to the minus 17 minus 14. They are very small, 0. K equals 2. So 1 plus 1x plus x squared. K equals 3. 1 plus x squared plus x cubed. K equals 4. 1 plus x squared plus x cubed plus x to the fourth. K equals 5. 1 plus x squared plus x cubed plus x to the fourth plus x to the fifth. K equals 6. 1 plus x squared plus x cubed plus x to the fourth, x to the fifth, x to the seventh. Again, 1 plus x squared plus x cubed plus x to the fourth, x to the fifth, plus x to the sixth, plus x to the seventh. K equals 8. 1 plus x squared plus x cubed plus x to the fourth, x to the fifth, x to the sixth, x to the seventh, and x to the eighth. This completes the use of the Taylor-Maclaurin SERIESSUM expansion and LINEST Polynomial Regression to generate the polylogarithm of 1 minus x raised to the power k plus 1 over 1 minus x.